So 2 weeks ago, I had the pleasure of trying out the glider product from Hexens, and we went through live, and I shared basically my experience using it, and writing some queries and even finding some cool stuff. Granted, it was on the Coven testnet, but we found some cool stuff, and we got to see how glider could be leveraged to probably pretty easily find a lot of high severity, bug bounties and uncover critical bugs at scale across all smart contracts that have been verified on the network. And of course, I thought the tool was really cool. I thought it was really useful. And we're going to do a follow-up on Ethereum mainnet. So what I ended up actually doing is being able to hop on a call with Vahe, who is a CTO at Hexens, and has helped them to really mastermind this product. And he shares a lot of alpha. He runs some queries on Ethereum mainnet with us live and sort of walks us through everything from, what can you achieve with the queries today, maybe, how you can optimize your queries, make them run faster so you can explore more contracts at a time, more functions, more instructions at a time. Shares a lot about, the power, the type of vulnerabilities that you can find, the type of vulnerabilities they've already found and disclosed with it. And then also talks about what's on their roadmap, what's coming in the future, and then how they see this being adopted in the long term, as well as some other cool stuff they've got going on with bug bounties and some zero knowledge proof solutions for proof of duplicate, etc. So overall, I had an excellent talk with Vahe, shared a lot of alpha, and we got to see the power of Glider once again, and got some tips on how to use it the best way. So in this video, I'm just going to show you, raw pretty much the entire session where I just went in with Vahe and we just both used Glider, and he walked me through a few queries and talked about the roadmap. So I highly recommend you go ahead and watch this and watch it to the end, because at the end he also covered some really cool stuff they're doing on the bug bounty side. So I hope you guys enjoy. Also, if you're looking for Ethereum mainnet access for Glider and you have some alpha, you want to try it out on mainnet and you want to get some bug bounties, go ahead and in the description below, I think in this session Vahe mentioned, go ahead and just send him a tweet or send him a DM on Twitter or X or whatever it's called, and just ask him to share why you want to use the tool, and then Hexen's team can maybe hook you up with mainnet access, and you could probably leverage what they've built to find some really cool stuff. So I'll leave that in the description below. Without further ado, let's get into all about Glider and Remedy. But of course, before we do that, my name is Owen, and around 2.5 years ago now, I've co-founded Guardian Audits, and ever since then, we've uncovered hundreds and hundreds of critical and high vulnerabilities across probably over 1,000 different smart contracts, maybe a couple thousand smart contracts at this point. And my goal with all these videos is to basically distill down, everything that myself and our entire team at Guardian has learned through all of these uncovered vulnerabilities and all of these smart contracts examined, and share them with you so that if you're a security researcher, ultimately you can become the best security researcher you could possibly be. And if you're a project or a developer, hopefully you can implement some of these best practices that we've found, and then one day come to work with Guardian and ultimately get the best engagement possible working with our team. So with that out of the way, let's get into Glider.
So the interface, if we just start with the interface, is basically divided into two parts. The rest is just, let's say, decorations. So on the left side, you have your editor where you write the glide or the query in a Python syntax. So this is kind of like a limited Python environment. There are lots of stuff that you can do. You can't import anything except Glider, for example, and there are some other stuff you can do. You can't use Python reflection, all the advanced stuff, but like you can write whatever code you want in Python. So you write your query here, you just hit run, as you can see. Let's say, I think this query took around 12 seconds, so we just give it some bit more time.
Yeah, and this one is looking for, what is this, like callback tokens?
Yeah, this query was created to find the ERC777 for entrancy bugs. I'm going to break down the query as well, and like on the right side we have the outputs, And this is already running on mainnet, by the way, not on the Covenant. So these are real contracts that we can check on. Like we have some results, statistics, whatever we have profiler here. Yeah, so what this query finds is the ERC 777 reentrancies, the ones that are based on the sender. Like there is this kind of, let's say, notorious, not famous, like reentrancy bug with ERC 777, where as this ERC allows the sender to have a callback, not only the receiver, like you have with NFTs, like ERC 721s, where the receiver can have a callback, but with the sevens, you kind of have a callback for the sender as well. So this brings to a situation where I kind of can show it on the real code. So with the results, as you can see, this kind of patterns where you kind of use a balance to get the balance of some token, then you transfer from the sender to the current contract, then you check for the balance once more. So if you don't really have a reentrancy lock on this function, and if the contract works with ERC 777 tokens, let's say if it's a bridge, that most likely, if it's a bridge, it most likely will work with these tokens because there's a lot of high liquidity 777 tokens. It is basically an extension of ERC20. Yep. So it's not like super deviation from ERC20. So there's a lot of tokens that are being used there. So if you do have this pattern, don't have a reentrancy lock or any mechanism that will block the reentrancy, you can reenter in the safe transfer from part, and you can inflate the amount that you're sending, because if the amount is based on the difference of after and before balance, then this before balance is gonna save the old value before you re-entered, and you can send the token just once, but every internal reentrancy call, when it pops out of this transfer, will call the balance off with a new balance, and every single nested call will give you the same amount, even if you have sent no tokens in the internal calls. So I might not be the best person to describe the bug vector, but like I think a lot of people know about this vector, and this exact query have brought us quite a big payout. So I think we most likely will eventually synchronize the, let's say, tweeting about and making this case public. But yeah, right now I'm not sure that I can disclose the names. But we have found this bug almost a year ago when we were still developing the glider, when we didn't have this website, and we found it in quite a big breach and reported it. So let's say let's see like how we find this kind of patterns. What we're looking for, basically, we kind of need to formalize a bit the logic that we want to match in the query. So we will be looking for balance of calls that have some subsequent transfer from, and then we have some subsequent balance of one more time. So it makes sense to start with finding this kind of balance offs, like interesting type of balance offs, and then checking that in the code we have subsequent transfer from and one more balance off after the transfer from. So we don't want the situations where it's like this, like balance off and transfer from. We want to have a transfer from and only after that one more balance off. So what we do here, and we have some nice comments here. So what Glider can do is it can work with code as with data, which gives you possibility to describe this kind of chains of filters and to get quite high, let's say, filter out entities that you want in very performant way. So we iterate over all the functions. If you call this function, it will bring you all the functions that are there in the Ethereum mainnet in all the open source contracts there. So, yeah, like we iterate through all the functions, and then we start to filter it. Like we filter the ones that are public and external, either public or external with function with one property. Like it's either external or public function. We don't want it to have modifiers with names non-reentrant, lock, only owner. So and yeah, and there will be a lot of parts where you can optimize the query, and I'll talk a bit about this later. We wanted to have an argument of type address, and this is a very interesting part with Glider, is that when we have filtered the functions, we can level down to its instructions and continue to filter down to filter out instructions as well. So we level down to the instructions of already filtered functions, and then we say, like, give me the functions that are calling the balance of. And we execute the query, and this 1000 is just for limiting the results. And like you can do pagination afterwards. You can just the second. It also accepts a second parameter where you give the offset. Let's say skip first 1000 and then give me the next 1000, whatever. You can get rid of the parameter and you will get everything, but most likely it will be just huge, and it will take longer, and also like maybe if your query is not filtering enough, you might end up getting just a lot of results, so you can't really work with it. So it makes sense to always start with some limit to check that your logic of your query is correct. So what we do, we have all the instructions that are calling balance offs. What we want to check is we want to check that there is subsequent transfer and the balance of call. For this, we just iterate over instructions we got, and for each one of them, we take their next instructions. For the next instructions, we're checking that if it's a call and it's a call to transfer from or safe transfer from, great. So we found this transfer from. What we're going to do is we're going to do the next instructions of this transfer from, whatever comes next, and check that there's a balance of. So we do exactly that. So we take the next instruction of the transfer from, and we check if that's a call, great, then it's got to be called to balance off. If everything has hit, we just append this, we just add this instruction to the resulting set. And the way how the query works is whatever you return in this function, your query logic should be written always in the function called query, and whatever you return here, you will be seeing on the right side. So as you can see, we ran this for the first 1000 results, and it executed 14 seconds for 14 seconds, and we have 2 results. So this one is called like growth coin staking, whatever the address, and we have the stake function, which is public. It doesn't have the modifiers that we don't want it to have. There's the list, and we also found the pattern here. So yeah, and moreover, like this required check doesn't really affect us, I think. So yeah, this is like I think I have seen this contract and I've checked, and it's not vulnerable. Because I've run this query a lot of times before, but like this looks really like it's on the edge of being vulnerable. If it works with ERC 777s, most likely it's vulnerable. Maybe I'm missing something. I gotta take a look at the contract to make a proof of concept. Sure. But like, yeah, whoever is watching this, or you, Owen, like you can check, for example, for some other contracts as well. And we have some other hit as well here. So we have ALO Vester, where I guess the function is for vesting some token. So it's external. It doesn't have the modifier we don't want it to have. And we have the same thing here. So it's balance of, safe transfer from, and one more balance of. As you can see, we're subtracting the balances to get the amount, so that's exactly what we need. Basically, if we vest, like it looks like it really should work, like from the code. Like if you vest a 777 token, you can inflate your vested amount. And I guess like after vesting, if you withdraw the money, you can get much more money that you vested. Yeah, and I most likely I've checked this contract as well. It's either like we can go to either scan. Let's see. I think it might be if I share this tab instead. So it's not even too old contract. It's
Yeah,
called
within the last year.
the token allocation. Whatever. Do we have some internal calls here? No, like it's not really. I don't think it looks like one that is being really used.
Yeah.
Yeah, but it also has some similars. So maybe some similar contract which has the same bytecode. Yeah, this one is being used.
Yeah, and usually these vesting contracts are meant to be used with arbitrary tokens, so it's definitely possible that a 777 would be used here.
Yeah, like I don't think I've investigated this one.
Mm-hmm.
Yeah, I hope whoever sees this, if this is really vulnerable, he does the responsible disclosure.
Yeah, before we release. Yeah.
Yeah, it looks like we can check tokens, like whatever. It looks like it's working only with their own token.
Yeah.
Yeah, if it only works with their token and their token is not the ERC777, then so maybe they're good to go. But yeah, share this tab instead. Let's go back to Glider. So yeah, just for fun, let's make the list a bit bigger. It will take a bit more time, I guess. Yeah, let's see what results we get here. I'm going to show a couple of more examples of real bugs that we found. So this is like a real query. It only took like around 30 lines of code, of which I don't know. There's a lot of comments here. So yeah, it's around 20 lines of code you need to code to get I don't know, payout for a couple of critical critical vulnerabilities. Yeah, as we can see, it's not only this. So we have 3 results. One more result added after enlarging the set to 2000. So we have some CCIP, send message, pay first step. So it's external. It doesn't have the modifiers we don't want it to have. And we have exactly what we need. So we have the balance of from token in, safe transfer from, and then current balance. And the real amount in is calculated based on the subtraction of these balances. Yeah, so this can be a real catch as well. So as the database is being updated every week on the mainnet, like there might be some contracts I've never seen so far. So yeah, there might be even some real scenarios, like real contracts that one can find with just this default. This query even comes by default, I think, when you open the front end.
Yeah.
but as just a regular user can only use in Covan testnet, we don't really see any trouble in this. So yeah, it's fun.
Yeah, and so is it updated every week then? In terms
of the mainnet is being updated every week. The Kovan is deprecated network, and that's like one of the reasons why we give access to everyone to the Kovan network, because there won't be new contracts that someone is deploying just, let's say, just before deploying to the mainnet, and you can kind of front run them on the testnet. Let's say find the bug on the testnet. Don't report it, wait for the mainnet, and then exploit it. So that's why we decided to give the Kovan testnet, so we can kind of be safe on this in that sense. Yeah. The people then, and we don't control that. We have lots of users registered and playing with Kovan. We're sure that there are no real contract already there. And sometime when Kovan was active, maybe, but like not now.
Yeah. In terms of like. So yeah, when you increase the sample size, obviously the query takes a little bit longer. Is there any alpha in terms of getting the query to be like as efficient as possible? Is there any kind of like special index that you want to hit when you can? It's been a while since I've been in Web 2, but any special database type stuff you can do with your queries here?
Yeah, so that's of course. So as this part is basically handled by a specialized database, the less joins you have, let's say, it's not a relational database, it's a graph database. You still have something called like something that look similar to joins. So the less joins you make, the better. And joins usually happen whenever you change entities. Let's say here we do have a join because we're filtering on functions. Then we change the entity. We kind of let's say we join the functions with their instruction. It's not really a join, as it's not like a relational database. It's a bit different, but it acts like a join, let's say. So if we join it with instructions, this join usually consumes time, so it makes it slower. But there are, like, I mean, for this exact scenario, there is no way I can do it without joining the instructions, because I really want to filter some instructions. So I guess I just have to do that. And another thing is, of course, the more unique filtering is put on top, the better, because it will just be handled with the same in the same way as you put here. There are some optimizations that the query, like there's an optimizer that optimizes the query, but it's not like working 100% of time. Like it has its own heuristics, whatever. So you cannot really rely on the fact that it will always find the best way to store the filterings. So yeah, the more stricter the filter is, if you put it on top, it will work better. And we do have a profiler stats here. So this is quite an interesting thing.
Wow.
As cool. It profiles line by line. So it can't really profile inside the filters. So in that sense, we're kind of like profiling the Python part, let's say. So this chain of calls, as it's actually one line in Python, we just use a syntax to make it multi-line, but it's just one instruction. So the time that it took will be, let's say, atomic. It cannot be divided by parts. You cannot really see like which filter took how many times, but you can kind of see that, let's say, by the percentage of time, the 30% of time took this instruction, filtering from the database. I think in time, it took 8 seconds, 8.2 seconds to get all the instructions that we wanted. And 19.3 seconds, it took this instruction.
So this was just
the second next instruction, like, took the most of the time. And like you can kind of try to optimize based on this statistics. The rest was so quick that it, like, we're giving you time with the granularity of 1 digit after the point. So it was way faster than this. That's why you have zeros here. Of course, it's not like zero. It's most likely some nanoseconds, but you don't really see it here because it was just too fast. But yeah, like you can see that this part, this for instruction took way more time than the database instruction itself. So you can kind of try to let's say you can try to optimize based on this profiler stats as well. Yeah,
we're gonna have like glider query golfers now, like gas optimization, optimize the query.
Yeah, there can be that kind of, like, we eventually we can come to this kind of usages as well when people start to, I don't know, maybe solely optimize the queries or whatever. Yeah, that'll be fun as well. So that's one example, some real stats. You can remove this, but it will take, I think, a lot of time, maybe like 10-15 minutes. Like usually when we have alpha, let's say if you have alpha and you just really need to check all the contracts out there, eventually you get rid of the limits, you run it, and it might, depending on the complexity of the query, it most likely will run for a couple of minutes up to wherever, I don't know, 10-15 minutes, 20 minutes. We've seen that kind of queries as well. If you have a decent query that really yields results, I mean, it's worth waiting for 10 or 15 minutes to get all the vulnerable contracts on mainnet. And mainnet is huge. Like, we're integrating some smaller chains right now as well, like, and let's say some other layer 2s, for example, they're usually around 20 times smaller than mainnet. And like whatever you see here, let's say, I don't know, like 29 seconds, most likely it will be just linearly lower amount of time for a smaller chain. Like, if it's 20 times smaller than mainnet, it will take like 29 divided by 20, It's around 1.5 second, I guess. So
Yeah.
so the same query would have taken a smaller chain, 1.5 second. So it basically depends on the sizes of mainnet as well, and mainnet is huge.
Yeah, in terms of just like literally the volume of code that you're just like indexing.
Yeah. I think there's only one chain that is bigger than mainnet. Like you want to try to guess which one is it?
Would it be BNB? Just all the
Yeah, exactly. It's Binance, because I think it was at some point in time it was so cheap that like everyone who ever even didn't know how to deploy contracts was deploying contracts on
Yeah.
BNB.
Yeah, just because it was cheaper. That was really it.
It was really very cheap, and I guess a lot of people have done some even testings, I guess, on the BNB mainnet. It's around 2 times bigger than mainnet.
In terms of like
in terms of verified contracts, of course. Like in terms of just deployed contracts, I'm not sure. It might be even bigger.
Yeah,
might be even like crazy bigger, the 10 times bigger, whatever. In terms of verified contracts, like unique verified contracts is 2 times bigger than mainnet.
That's a cool trivia
Yeah.
stat.
By the way, I'm not only looking for security stuff when I work with Glider. Sometimes I did some fun researches that I'm thinking to put out there in Twitter, where I was trying to find let's say the contract with the biggest name, the function with the biggest name, with the longest name. Like, and they're so crazy. Like the contract with the longest name deployed on Ethereum is just one guy telling, without spaces, telling why he's thinking of leaving Web3 as industry, and he's like, it's like a story.
Yeah,
in the name of the contract. What? Sorry?
Is it all in camel case?
Yeah, it's all in camel case. Yeah,
awesome.
Without spaces.
Yeah. Dude, those are great like shit posts to promote Glider.
Yeah,
you can find with the product. Yeah.
Yeah, I'm just too lazy for it. I really don't tweet much, so yeah, I'm always like postponing it. Okay, like I'm gonna. Yeah.
Oh no, I was just saying that's awesome, dude.
Yeah. So one more query that brought us some real reports and payouts is about. Most likely, you've also heard about this tech vector where like UPS proxies, when you have an initial, like you have like delegate call inside the implementation, and you don't call the initialize on the implementation. If let's say if you only call the initialize on proxy, which like makes sense to, of course, you gotta call the initialize function on proxy. But if you don't call initialize on implementation and you have upgradability logic inside your contract, then if like I can find these contracts, I can call initialize, upgrade the implementation to whatever I want to, and of course, as an attacker, I would want to upgrade it to a contract that self-destructs, and like I just call the self-destruct, destruct the implementation, and proxy just, it's not only freezes, like it just breaks up all the protocol, and you cannot upgrade the proxy. You're gonna be freezed with the logic, which just it being, self-destructed, and that's it. And most likely, even for some cases, however the protocol is written, you can even steal the money. So we were trying to find this kind of contracts. So we were thinking of, and there might be some similar thought process when you start writing the query. Let's say when I'm trying to formalize, like I want to find implementation contracts, but like you can't really find implementation contracts because it's very hard to formalize how the implementation contract looks like because you don't really know if someone is calling it with a delegate call or not. Like it's not really trivial, and like basically every contract can be an implementation for some proxy. So the best thing that we came up with, and it turned out to be really great in reality, is just to find contracts that have initialize function. We can't put any filtering on the arguments, but it definitely should be called initialize. And I think when we were analyzing these results, I think that maybe we didn't even have even single false positive. Let's say whatever contract had initialized function was an implementation. I think it was something like that, or maybe the ratio was so small that like we just forgot about it. So one of the ways, like you gotta end up in this kind of thought processes where it's not too obvious how to formalize something, but yeah, like you can always come up with some solution. So let's think of what we want to find in the contract. We wanted to have initialize function. We wanted to have delegate call inside it. So because a lot of implementations don't have any any delegate calls. So even if I call the initialize, I can't self-destruct that contract. So I need some controllable delegate call inside the implementation as well. So transparent proxies, for example, most of the transparent proxies won't work. So I want initialize function. I want delegate calls in the contract. So one way to fight with this vulnerability is to either use an modifier which comes with OpenZeppelin standard library, which is called initializer. If you put this initializer modifier on constructor, it blocks this, so you cannot call initialize function afterwards. And another way is to call disable initializer inside the constructor. So we don't want this modifier and this function in the constructor code. We want delegate call, and we want it to be implementation, let's say initialize function. That's how we started. We find all the contracts that have function with name initialize. Then we check for the constructor. We say if it doesn't have constructor, that's great, because you cannot have any modifier or function calls in it. The only thing that we're left to check, if it doesn't have constructor, we need to check that it has some delegate calls. What we do, from contracts, we just go to instructions through chaining, like contracts, its functions, its instructions. We take the delegate calls, and like if we have any results, the length of results is more than 0, greater than 0. So we just append this contract because it doesn't have constructor. It can block us anyway, and it has some delegate calls. So that's an interesting contract for us. If it does have a constructor, then we gotta check this calls as well. So this blocking functionality as well. So we take the modifiers of the constructor and we check that it has no modifier with name initializer. If it does have, we just skip. If it doesn't have, we check for the delegate calls. If we don't have delegate calls, all good. And the last check we want to do is to check that the constructor, whatever function it's calling inside the constructor, there is no function with name disable initializers. We take like callee functions of the constructor. This gives us the set of all functions that are being called from within the constructor. And we use this filter with name, like disable initializers. And we check that there's no functions with this name called in the constructor. If all good, we just append the results and we return. And we have a bunch of from the first 1,000 implementation, we have 78. And with this bug, basically almost all of these contracts are vulnerable. The thing is that when we started analyzing the outputs, most of them where eventually the initialize function was called on the implementation. So they didn't have this protection, but at some point the deployer did call this function on the implementation as well. So what we did eventually, and unfortunately we don't have this feature right now in the glider, something that we're working on as well, is we eventually got this JSON of the output. We parsed all the contract names. So actually, we just download the JSON and we write a very small Python script that takes this contract address and just through whatever node API you want to use. It can be either a scan API, it can be some other API, it can be node, whatever. We just wrote a checking logic that we check that this contract, whether it had anyone calling the initializer function on it or not. And we ended up with maybe 4 or 5, something like that. I think it was a bit less than dozen. So yeah, around 5, I think, contracts that were out there, real protocols working and they're under risk like at that exact moment. And we started like this coordinated responsible disclosure to help them out.
That shows, this one in particular shows the power of like how detailed you can get with a query, like down to, at least at the code level, every single one of these contracts were, technically vulnerable to this at some point in time, just based on the code that was there. So that's really cool. Like, I mean, it shows the power of like implanting this inside of Python and then just like, do any arbitrary logic on top of that. Yeah, I love that one.
Eventually, what we're thinking of is that we want to add state filtering functionality as well. Is that it's not an easy thing to do, to be honest. And also, given that we still have a lot of things we want to improve with the main engine, so there's still a lot of stuff we'll be doing with this, which is just this part. So we don't have it right now, but I think by the end of the year we might be ready to ship that as well. And I think like in there's two parts where you can query code and then you can like cross check it with some conditions with the state. Let's say whether it is working with some token or whatever. Like that'd be crazy. I think that will even yield like way better results in that sense. For example, with this ERC 777 tokens, instead of just going rechecking every single contract to see if it works with ERC7s, you can just add some filtering in the query, checking that whatever address it has been working with, if there is at least one that is complying 777 policies. Like if you mix this code plus state queries, I think it will be really very impactful.
Yeah, and I mean that's super advanced, because like even if you think about what the company that GitHub acquired to basically like grep all of code on GitHub, that's just looking at just literally the code. But if you were to add a feature where you can read from storage for some of these variables, that's like being able to go directly to the live production version of the code bases and like read from their database. If this was like put into Ubuntu terms and see like based on the physical state of the application at this time, is it vulnerable? So that's really cool.
And one of the things that we might ship quite early, like let's say in the very foreseeable future, is that, and we've been asked about this a lot, and we have been victims of this as well, let's say, of lack of this functionality, is the recency check. So like people want to check, people don't want the very old, dead contracts that nobody used. They want recent ones. And this is something as that's also part of the state. Like it doesn't really, you can't get it from code. Like code is just out there. From reading the code, you can't tell whether it's old or new. But we want to make at least one small feature in the interface, which is not in the query itself, where you can get the results. Let's say hit some button and it will do the recency check for you and filter out the ones that are dead. So that's what we might end up shipping quite soon. So people can filter out some dead contracts automatically and not go and like just one by one spending more time on it.
Yeah, another one would be cool is like contract balance. If I was able to see like how much money is in this, and then you could sort only for like the most impactful.
That's I think that would be also a very important. But there's a bit of small complication with that, is that we don't want to give you only Ethereum balance. We gotta give you token balances as well. And usually the contracts, they have a lot of spam tokens. They don't have real value. So we're still thinking about it. But I think that's also that's a great idea. We should add that as well. Kind of somehow try to find, like, let's say an average market price of the tokens or whatever. Like pretty much the way either scan shows it. Let's say.
I was wondering how they did it. Do they just query like CoinMarketCap, and like how do they determine whether it's a game token or a token that actually has worth?
I think so. I think most probably they used CoinMarketCap or at least something similar. Yeah, we might end up using either a scan API. Luckily, I think they do give it with the paid version. We of course do have some paid versions of their APIs, or maybe we will just create one for ourselves. Let's see. But yeah, that's the two main things. I think the top one is recency, and the top two questions that we got is whatever you said. So it's about the balances. So yeah, that can, like, this separately, these two, let's say these two features, we can ship it quite fast.
Yeah.
But in general, to be more sophisticated, like to ship a more sophisticated state querying, that takes a lot of time because as code base is quite big, like we kind of work with big data. So this stuff, yeah, when writing queries, like you gotta understand that you're really working with big data. There's a lot of stuff. Like there's around a billion, like a little less than a billion instructions in our database, and that's like only instructions. We have hundreds of millions of functions there. We have millions of contracts. It's huge. It's really huge. So the fact that you get the results in I don't know, a couple of minutes, I think we can optimize it. We can still optimize it quite well, but I think it's already a not so bad result, let's say, given the amount of data that you're processing.
Yeah, no, I mean, well, also the fact that you can like limit it to the first 1,000 or so helps as well.
That proven to be very helpful because usually when you write query, your query has a lot of flows in the logic and a lot of cases that you forgot about, and you kind of need to explore first. So you take, let's say, the first 1,000 of results, you do the analysis, and then you find out, oh, I forgot about this part. I gotta filter out this part as well. And you might end up having just some, I don't know, regular bugs in your code. That's like, this is Python, you can just end up doing something wrong. So yeah, maybe you have just bugs in the logic. So you kind of play around until you get to a stable version of the query, and then like you can just get rid of the limit parameter and get all the results.
Yeah. And then is there currently like a JSON export feature in the UI?
Yeah, it should be. So if you hit the download file, you should be able to download both the lab, like you download this query and you download the output as well.
Okay, I see. So like if folks want to take the output and then run it through like some kind of API, if they want to go to the API, they can do that.
Yeah.
That's awesome. Cool. So I think, is there one last query here we want to go through?
Yeah, I don't think this one is too interesting. Like it's super trivial. I think it just was some query that I actually just hit the button on. Yeah. So let's just look what it does. So it finds the functions with prefixes burn and underline burn. It checks them to be external or public. It should have an argument of type address. Yeah, and should not have modifiers. So that's basically, this is a playbook example. Like we kind of try to find burn functions that anyone can call. I think from the results when we spend allowance and then burn. So I think a lot of results here are not really exploitable, let's say. You gotta work on this query a bit more to find situations where you can really uncontrollably burn. And also this kind of stuff, like anyone calling burn, whatever, I hardly believe this kind of bugs nowadays getting to deployed, mainnet codes. I think I can still believe that there might be. It's like you can analyze this, or you can write whatever much better written query to find them. I'm not saying you will not get real results. Most likely you will find one or two, but most likely you will go through a lot of dead contracts as well during that process.
That's true. But yeah, I just remember there was one that was like exactly, it would have been caught by this. And I just remember it because the guy who called it got like front ran, and then he got wrecked. The guy that was trying to it's like the funniest turn of events.
Yeah, I mean that's the funny thing, that the mempool is actually like a Wild West. Like anything can happen whenever you broadcast your transaction out there. Yeah, there's a lot of crazy stuff that can happen.
I mean, especially for something like this that's so blatant. First of all, obviously the recency thing will be huge for that, but also like some kind of alerting system or some kind of integration on top. That would be really cool you could like build your query, then you could set it and be like, hey, check this every time the contracts get updated. That would
Yeah.
be really cool. Have some kind of webhook or something.
Yeah, exactly. That's definitely a thing that we're going to ship, as we were thinking to give possibility for security engineers to really get, let's say it can become a passive income revenue stream
Yeah.
or whatever. Like you just write query once and it just passively brings you money. Let's say it's constantly out there working for you.
Yeah.
Whenever someone hits, you just get notified about it. Yeah.
That's awesome. Yeah, this is going to enable a whole new like world of income streams for security researchers. So I'm all for that.
Yeah, I hope so.
But yeah, that's awesome. I mean, anything else you want to share? Any
Yeah.
features that you guys have in the pipeline that we didn't already talk about?
Yeah, I think it would be nice to tell a bit about the roadmap. I will tell about the roadmap, what we're planning to do, and also before that, there are a couple of things that I want to mention about the interface and how to approach this. Already broken down a couple of examples, but still, when you write query, like you kind of need to understand what kind of functionality the glider has, like whether it can do this, or maybe you're not sure that this can be done. Like we have the documentation link here, which redirects you to the Git book that we have for glider. And there are some introduction pages here, and we have an API section. The API basically is describing all the classes and all the methods that we have, with examples of how to use them, with examples of outputs. So yeah, eventually you want to be right here, usually just jumping from one tab to another.
Yeah.
As the experience shows, that's mainly how you can use it. So we have documented here a lot of stuff. There's a lot of functionality, and you can search here, like whatever I can do. I don't know, with Coley, whatever names, let's say, like you can get all the stuff here. You can see examples and outputs for them. So the documentation is your friend. Let's say it might end up that you spend more time on the documentation rather than just writing the queries. That's totally normal. Yeah. And if we go back to the glider page, we have like a shortcut version here. This basically is connected to our Gitbook documentation, so you can kind of see functionality here as well. You can use the search as well, and if you just press on the links, you go to the articles where you can see exactly the same thing here, whatever you will see in the Git books. So you can, this like a shortcut way to find functionality that you want to, and also, let's say, if you want to copy paste something, you can just copy paste it. So we've built this to ease the process of referring to the documentation and writing queries. There's still a lot of stuff in this interface and user experience part that we need to improve for it to work much smoother and be much more helpful. Yeah. So that's the documentation.
One thing that I find helpful, it's like when you're writing a query, there's like auto suggest, like auto complete as well.
So an important part, of course, about that is that all the magic comes from this. When you import like when you do the from glider import everything wildcard, like it starts suggesting you the functions. Technically, you can get rid of this and the query will work. But if you get rid of this part, the IntelliSense part will not work. So it will stop suggesting you like whatever you can do. All the IntelliSense stuff. Yeah, so I guess that was it from the documentation part. And one important thing is that, I totally forgot, like the results that you have here are unified. I don't want to say by the source code because it won't be true, but a much better unique thing, we kind of unify the contract based on init code and bytecode. Like it doesn't matter how exactly we unify, but let's say if there's two exactly same contracts deployed, exactly same, we're going to show you just the one. Like right now, to find, let's say, this contract, if you want to find the similars of this one, you can use the header scan similarity check. There's the stuff on the either scan. We're working on a way to show you the similars here as well, but we've done this on a reason because, as our experience shows, most likely whatever you want to find, if it's a normal, let's say, protocol, whatever, if it's not some crazy scam, it will be unique. But there are so many contracts that have like crazy amount of duplicates. Let's say there is a contract. Honestly, there is one contract that has 10 million duplicates. Like, let's say if you find something in its code,
Like
we're gonna show you like we need to show you 10 million addresses. Yeah, we have this kind of stuff we're thinking of. It was I think Bitstamp. Have you heard about an old exchange called Bitstamp? There was a centralized exchange once, a European one. I think it was called Bitstamp.
Yeah.
So at some point, I think they did their user deposit addresses. They implemented via contracts, like not like the Binance has. Like it's kind of like a hot wallet that uses just private key. You don't have the private key. They used contracts, and whenever someone registered, they deployed the contract, the deposit contract for you, and it had the same bytecode. Like it was just exactly same for everyone, and there was 10 million, or more than 10 million. I'm giving you like I'm not exaggerating. It's just more than 10 million duplicates. And of course, like a lot of different crazy stuff as well. Like if you look at how many Uniswap pairs are out there, around 500,000. Like, so yeah, I think I just started talking a bit off topic stuff, but yeah, the main idea is we're giving you unique results. If you're thinking about similarity checks, you can do it through via Etherscan before we ship you convenient way to see that in this output as well. So it actually helps you and not vice versa, brings you a lot of trash information that you really don't need. So yeah, that's about some information that I wanted to put there for people and about the roadmap. So the top priority stuff that we have here is that the cornerstone idea behind the glider is treating code as data. And you kind of see this very easily in this parts where you work with database, where we chain these filters, like it's purely declarative. It's working as a data. It's like filtering some data as well. And you kind of see a bit of mixture of imperative code when you already got the results and you need to do some analysis here. Like we want to shift even this part to be more declarative. The main thing that we're working on is that it should be as easy as it possible to write this kind of stuff. And the declarative format usually is way more convenient for people, to start using, and it's quite easy and more, let's say, intuitive with how to work with code. So we want to shift this part. We want to ship a lot of functionality and do some refactoring. Some of them will refactor some core parts as well. So we want to do some refactoring so that even this part becomes much more declarative and easier to write. Basically, I would say our goal is to create smaller and smaller queries for whatever you want to. Let's say if we now need 20 or 30 lines, ideally we would want it to take, 5 lines, 10 lines, whatever, so that the person who is writing the query is doing it with much easier, and much faster to shallow the learning curve. So that's generally the direction that we're going. We want to do some refactoring and add functionality. So in that sense, the glider is still quite an active development process where we can add new functions, new classes, giving ability for people to filter more stuff, to do it much faster. And the performance is another milestone we're working on, is to make it as performant as possible. So that's what we want to do firsthand, making much better experience, like creating much better experience for people who are writing queries. So you run the queries faster and you write the queries faster, and shipping this small features, as I said, like a recency check, and also both like a balance check also will be shipped quite easily, and maybe in the same release or whatever. With if we zoom a bit out and we talk about some bigger plans, the bigger features we want to deliver are a way for people to use it not only for deployed contracts. We want to integrate it in CI/CD pipelines. If you have a repository of code, it should work with it. It should also work with some local files. Let's say you're a developer, you have your project in some folder, you can upload it and do some checkings on there, run some queries on the code. So we want the glider to be working with any kind of code, not only the contracts that are deployed on blockchains.
Yes.
That's one of the bigger features, and let's say, that we want to ship. And of course, partially we talked about it is of course the state.
Yep.
The state is only applicable in terms of deployed contracts. Of course, if you have just static code in your folder, it doesn't have any state. But like for deployed contracts, we do really want to have a state. I think that would be great because you can go very, very deep in your analysis and you can get rid of a lot of false positives, and it can yield you like great results as far as we understand.
Yeah, and it also just opens up like a whole new space of bugs that could potentially be like sort of nitpicked apart that otherwise I don't think you'd really be able to get to. So yeah, I think that would be huge.
Yeah, exactly. There'll be a lot of fun stuff you can do. Let's say you can do cross-function queries, cross-contract queries. Let's say the query one contract, you see that it does an external call to some other contract. If that other contract has source code as well, you can kind of follow and do analysis on this new contract as well. It was never available. Like there was no way you can do this until you can do it even with the glider that we have right now, but that's why we want to ship that functionality as well, so you can do cross-contract queries as well, and a lot of great stuff. Yeah, like checking balances, checking type of tokens they're working with. Maybe you have found some. Let's say we have seen hacks, some hacks that are based on the fact that if a protocol is working with some deviating token, say double entry point token or whatever, like you can just start filtering from there. Like if you know about some weird token that is acting quite weirdly, like it's not vulnerable by itself, and there are a lot of protocols that work with them and are not vulnerable, but there might be some edge cases where someone works with this token in an incorrect way. You can kind of just through the state filtering, you can find all the contracts that do work with them and then do your checking on the code query, like continue your code query.
Not even beyond tokens, like I'm thinking like, all these systems, like as time goes on, it seems to get more and more
composable,
composed, and everything seems to get even more like mangled together. And like there's a vault compounding this vault that's compounding that vault. And so, if you find, because so often I see with these complex integrations, there's one like really esoteric thing in the underlying protocol. And then if you can just take that and then say, hey, I want to look at everything interacting with this protocol router here and find that esoteric thing in everything. I could probably try and do that with like some GMX v2 stuff I have in my mind right now. But so I think there's a ton of potential for that kind of niche knowledge, because I think the bugs that are kind of applicable everywhere, like the 777 stuff you have here, and then like the public burn, that stuff that people will be going through that every single week to see if they're contracts. But I think the alpha for security researchers who want to come in and like they want to get that those payouts with Glider, it's going to be in those niche protocols where it's like you've got some alpha on like, the GMX v2 order handler does this, and it's unexpected. Today, I think you can get to a lot of those. So but I mean, obviously adding like specific targeting and like multi-contract parsing, that would be really great. Yeah, and I mean the corpus you mentioned, like making this work for like a CI pipeline. I think the corpus of all the queries that get built up, that's going to be immediate test coverage that every single smart contract can go through. So that in itself is like extremely valuable.
Yeah, like the reason we want to ease the process of writing the queries is not only, let's say, just for it to be easy, which sounds great on itself as well. And that's the reason why this tool is free. and we don't want to charge for this tool anything, is that we want the community to let's say this kind of tools needs to be distributable. You need to have a way to distribute it to community, so community can start contributing queries, because that's the only way you can get to a good amount of, let's say, coverage of different type of vulnerabilities. Do it and do it with quite a good false positive versus true negative ratio, true positive, sorry, ratio, because that's the main problem with the static analysis tools, with any kind of, let's say, automated tools, is the false positives. Like, you can either find very niche stuff, or you can write a generalistic query, but the generalistic query will give you a lot of false positive, and niche stuff is not enough. And if you make a tool that is easy to use and easy to write, more people can write. And if a community starts writing gliders, that means that you can get a lot of niche queries, but in conjunction, like in total, they cover a lot of stuff, and that brings you a big coverage with a way better false positive ratio. So yeah, that's eventually, like, if you want to impact the Web3 on scale, you got to do something like that. Like, you got to do something that is scalable. So that's what we're trying to do. We don't even take commissions for whatever you find with Glider. At least, like, we don't have any plans on taking on that. It's free to use. Yeah, we kind of moderate the list of people who can use it, but that's for I think obvious reasons. Yeah, and yeah, we kind of thinking, as I already said, when we're talking that we're thinking of ways how to work on the number of people who can have access to the mainnet. So for it not to always stay very limited, as more people, there's still a lot of people who can bring value, not harm, but real value, and kind of want to use that as well. Yeah.
But yeah, I mean, in terms of features and roadmap, that sounds like we got some exciting stuff coming. Any alpha on like what the potential next chain would be, or if there's another chain in the pipeline?
Yeah, there are some, but unfortunately that I can't name the names. Yeah, because we're still in the process, and we never talked about whether we can go public before, like, during the process. Of course, like, when we do integrate, you're gonna say it, but like, yeah, I don't really remember on what kind of NDAs we have right now, or maybe we don't have. So I will just
be safer. Yeah. But yeah, that's exciting. We'll be looking forward to that announcement, and then hopefully, probably an announcement of a few disclosures that were made on that network shortly afterwards using Glider. So yeah, we'll keep our eyes peeled for that. Yeah, anything else you want to share in terms of like folks going to use this thing and try it out?
Sure. Like, I would highly encourage whoever has any kind of alpha, is if you don't have, like, as the amount of people are limited and we moderate them, please just ping me in Telegram and Twitter, whenever you can find me on my email, and we can arrange you either an access. Most likely we'll hop on a call, get to know you, and maybe give you an access so you can query your alpha and find all the projects that you can help out, or maybe we can do it, you can do it with us on a call. We can run it. We don't really need as I've seen this kind of comments, I think, in Twitter. I have some short discussion with some of the hunters, which are saying like, oh, you just want our alpha, like, not really. We're not really that interesting in that sense. Like, I'm not saying that your alpha is not good. No, like, it's really good, but that's not like what we're thinking of. Like, it's not in a part of our vision. Like, it's kind of like interesting to see, okay, like, what does this guy have? But like, we're not hunting that. Like, we're not really interested in your alpha. We are interested in the sense that we want you to really find all the projects that are vulnerable to your the zero-day knowledge or alpha knowledge, and to really help them out. That's what that's the only perspective how we're interested in your alpha. So yeah, if you have something in your mind and you're like, I don't have the access, but I have this super impactful stuff, or even you're not really sure how impactful it is, just ping me, and we can arrange all this stuff. That'd be great. And of course, like before getting access to the mainnet, play around with Kovan. I do understand Kovan is not that interesting as mainnet. I mean, obviously, everybody wants to work on the mainnet, but like you still, even if I give you access like tomorrow, let's say, you still need some time to at least like understand how this stuff works. Maybe a day or two. Yeah, like just you can go around. Do it now. So whenever you get access to the mainnet, you're just straight ahead going to run your queries and help a lot of projects and earn a lot of money.
Yeah, like you can write the query that you're going to use on mainnet, and then as soon as you get it, run it again.
Yeah, you can kind of polish it, do some optimizations. Yeah.
Well, that's great, man. So first of all, I'll go ahead and put your Twitter in the link below, so folks can reach out to you if they have some alpha they want to try it out. But yeah, beyond that, I'm excited, man. I'm excited for what the future holds with Glider and the suite that they have at Remedy. There's also, I don't think we even really mentioned it, but there's all these bug bounties. There's also like you guys have like a zero knowledge bug bounty proof.
Yeah, I can go real quick on this. Yeah, thank you for reminding me that it's not only the glider that we have.
There's so much to it.
Yeah, so if you hit this button, you can switch to the bug bounty. Am I streaming it, or did I change the tab? Okay, yeah.
There we go.
Yeah, so we have a bunch of programs here. Let's say high to low. Like we have Scroll, Polygon, we have some $1 million bug bounties here. We have 1 inch. We have some smaller ones that are waiting you. And by the way, this kind of mid-sized projects are where most of the money is actually, for Bug Hunter, because not everyone has looked at this kind of code. So yeah, a lot of different stuff that I can tell you about the Remedy bug bounty part. I don't want to go very long on it, as we already talked a lot about the glider. The important thing that I want to mention is, if we go to documentation, we have this ZK proof of duplicate thing. So I think this is very important. I wish I can show you from Treasure's perspective, but like fortunately it will include a lot of confidential data in the video. So yeah, I will try to show it in the documentation part. So the issue that we're trying to solve is the duplicacy stuff, and we have been also we've seen this kind of problems by ourselves as well when we report something and then a project just comes up and say it's a duplicate, and there's like no proof of it. You gotta trust, the only thing you can do is just trust whether they are, even if you don't trust, there's not much you can do, like even in that sense. So what we are doing is we decided to get rid of this problem where you need to trust the project, and we also got rid partially of some problems from the project's perspective. What we do is whatever is getting reported to Remedy, we're hashing it with a special hash called Poseidon hash, and we commit it to ZKVM blockchain. So this is done like whenever you report something, the hash goes to the blockchain. This is done for a reason, so we can kind of, let's say, commit the timestamp of your report. What happens next is that whenever someone comes up and reports the same stuff, or whatever, maybe some part of it is duplicate, not the whole report. So either the treasure, our side, or the project has the ability to generate a zero knowledge proof showing you only parts of the report, or maybe they can like go ahead and show all the report, whatever. In that sense, if that would be the only case, we would not use the ZK. The ZK is used for the purpose to show only part of the text of the original report, because usually projects, they don't want to disclose whole vulnerability, a whole report, because a lot of times there's not only one bug, there's a chain of different bugs. They don't want to disclose you the proof of concept, maybe some other confidential information from the original report. So there is a possibility for the project or treasurer to choose some parts, highlight it, and mathematically prove that this is part of the text that has been committed, let's say, 1 week ago. And like you can check that it was committed 1 week ago because it's committed to the blockchain. So we can't do, there's nothing that is, let's say, proved by our side as remedy website or platform, or from the project side, as you transparently see the timestamp of the commit, and you also see the highlighted parts. Oh, by the way, I forgot that I'm in the I'm now in the office, and I can show via this demo site. So this is a demonstrational site which we use just to demonstrate how the ZK proof works. In fact, in Remedy, you will not do all this stuff that I'm doing right now. So let's say I found critical vulnerability. Let's say PRC7 entrancy in breach.sol online. I don't know, 777, whatever. So let's say this is, of course, this is not like a real report, but let's say this is a report. So I hash the data. It takes a bit of time because it's solely done on the front end. We don't send all this information to the back end. And we have some Poseidon hash. Okay, it's like 242 and I don't know, 235, whatever. So 242 and 235. So we've committed this to a blockchain where you can see the timestamp. And let's say I go to proof. Someone comes up with a duplicate report, and me as a treasurer or project, as I have the original report, I start generating proof. I say, let's say I don't want to release everything. I just want to release this part. I don't know, breach sol and line 777. Let's say these are the only parts I want to disclose from the original report. So I hit the generate proof. It takes a bit of time as it's only the browser does all the ZK math. Take just a couple of seconds. It will give me two JSON files, the proof and the public information of the report. Okay, I think we're almost ready. Yeah. So I can like download these files. And when I'm saying like you don't need to do all this stuff in the thread, I'm also about all this downloading and uploading these JSON files. It's just built in the thread. So you don't really need to do anything. And let's say you somehow transfer these JSON files to the hunter for him to verify. I put the public JSON here and I put the proof JSON here. So if I hit the verify button, so I see that this text is part of a bigger text, and we kind of like, you can't even know about the exact about the exact lengths. So it's part of a bigger text whose hash is this, whose Poseidon hash is this, like 242 and 235 at the end. And it was like, we also give you like a transaction link where you can see that this hash has been committed, let's say a week ago, a month ago, 1 day ago, whatever. Like you get pure mathematical proof of your report being or duplicate, and not just, you don't need to believe us as remedy, neither the project as the one who's let's say was as a counterpart, whatever. So you don't need to trust anyone. You kind of get your mathematical proof of your report being duplicated.
Yeah, this is something that you just hear over and over again how unsatisfied hunters are with the current experience. And like, of course, this won't solve all of that, but I think at the very least, like, I'm sure there's so many cases where protocols can just say, oh, it's a duplicate.
Yeah.
And like literally not have any proof. So I think this is really the only way to fully solve that issue. And you guys are the only one, I think, out of all the platforms that has actually like gone and fully addressed it. So that's really cool.
Yeah. So and if we have a bit of time, it will take just 1 minute. I can also present like the short roadmap for this ZK part as well. Like it's not a big deal. It's not like super. It's not that complex to write this kind of stuff. It's, let's say, it's not a glider that took us I don't know already 2 years and we're still developing it. So the idea behind this is right now, as we do commit ourselves to reports that come in Remedy. So in Remedy, we can prove that it's a duplicate for whatever we have received in Remedy. Like if the project has already received the report in Remedy and not from some other bug bounty or let's say from an audit report. So what we want to do, this website that you're seeing, we want to bit improve it. So it can work with, let's say, Wallet Connect or MetaMask, and you can report whatever text you want to. So you can report, and we can also give APIs for, let's say, other bug bounties. If they are willing to integrate this, they can kind of commit or everything that is being reported. Protocols, when getting audit reports, they can just that it can just become one of the things that they do with the audit is just to upload it here and commit it to the blockchain. And that's the second step. And the third step is if you give this kind of a tool that is giving you ability to verify duplicacy, that means that whoever will not do this, if you give, let's say, a lot of possibilities for the protocol and projects to commit this and then prove it, for whoever doesn't do this, it becomes like a real argument in a sense, like, why don't you give me a proof?
There's no reason,
yeah, because right now the project can say, sorry, it's a duplicate, and it's like 50-50. It might be really a very ethical project who is not trying to scam you or whatever. It is really a duplicate, but it's a confidential part of a confidential report. They cannot show you, and they're like, okay, I can't do anything. You just need to trust me. And a lot of, unfortunately, I think the bigger amount of cases is just projects trying to, trying to play with hunters and scam them and just not pay the amount they need to be paid, that need to be paid. So I think whoever doesn't generate the proof after we've given this possibilities, like a lot of possibilities for them to do it, will automatically be affecting their reputation. And I think in this way, we can kind of push projects to be more transparent and more ethical. Because honestly, I've seen that a lot of people are so annoyed with unethical behavior of projects that I can wonder that maybe the projects themselves are actually the reason of some people going black hat instead of white hat.
Yeah.
Like it's of course, like it's, you should never do that. But I think that a world is a place where you cannot control everything, and some people will eventually still become black hats. And I think the projects that act unethically are part of the problem of some people, who are very bad at making decisions. Let's say they decide to eventually, I don't know, switch sides or whatever we can call it.
Yeah, and I think it's interesting that, by way of having this, you'll almost cultivate a cross-section of the projects who are, more friendly to bug bounty hunters when they come on the Remedy platform. And so maybe that creates just an overall better experience just on whatever project you're interacting with. Maybe that will ultimately end up in like, hey, you have more security researchers looking at Remedy, you have better security researchers looking at what's on Remedy, and then more projects will want to come on, and then ultimately it will just become kind of the standard is like, hey, you got to be more fair, and we can have stuff like this in place that it's
much like as Glider, like is free. By the way, our bug bounty platform is also fully free. We don't take any commissions for anything, success fees. We don't take anything. Even the triage right now, and we're doing professional triaging. There's a couple of things I can tell about that as well. Is that we try the people who triage your reports are like real auditors. They're not let's say they're not triagers, they're auditors. Like they know their stuff. They're always on the edge of whatever is being researched in Web3 security, and not only Web3 security as well. So there's people who are really understanding what's going on. So that's the people who are triaging, and it's free for now as well.
Oh.
So we've seen how like, let's say, other platforms are working the model that they have chosen. We kind of see problems there as well. We don't believe that like getting fee from the successful payout is a good way to do it, because it kind of breaks your incentives, as the bug bounty platform should be. It should be like an arbitraging party who's not like unfairly interested in the outcome, whatever outcome it is, like whether it's paying or not paying. Like if you get money when people got paid, like that means that you are incentivized for people to get paid, even when it might not be the case. So what we're trying to do, we're trying to fight for the fair outcome. Like if the hunter really needs to get paid, we're gonna do all we can, and we can use all our network, and it's quite powerful in Web3. We know all the big projects, they know us, like we know a lot of people. Like we can leverage that to help you to kind of push the project to not go, to do the right, to make the right decision and to pay you out the amount you need to be paid. But if you kind of try to trick someone and the project understand that this is not a report that I need to pay, so we can do the same thing from their side. Like we're just on the fair side, because we don't want to get paid just for people to paying bucks. Just pay them. Like this is great. Like pay as much as you want. Like you can even add something on your regular payout as far as we're not getting anything. Yeah. So like what we're more thinking of is that, for example, I don't really see that we can keep the triage part free indefinitely. That's like, that was part, like we had this idea from very start. We understand that at some point we can do it for free because it's like super expensive. As I said, our auditing part is kind of switching weeks to do triage versus audits. So we have this stuff as well. So as you really get trashed by real auditors, it's like super expensive. But if you really want this high quality trash, like, okay, you can pay for that. I'm not really interested there in any kind of, like, I'm not interested in the outcome. Like I'm helping you with the process, and that's why I'm getting paid. So we want, like that's why we're treating it, and that's why it's like fully free. And right now even trash is free. Like by the end of, I don't know, this free trash that we're doing, when it will become paid, let's say, you can choose not to pay and trash it by yourself, but it will stay free. Like you can just use the platform. So yeah, that's this couple of words I wanted to add about bug bounty. Thank you for asking. Also,
no, absolutely. No, I mean, it's crazy that all this stuff kind of, has come out all at once in the initial form, and then obviously all of it's going to continue to iterate on to just go from where it is now, where I think it's already got a ton of use, to probably just being, I mean, if you make just even a few of these changes where, you've got integrations with other bug bounty platforms, and then you're also read state in Glider, like this is going to be next level. But yeah, dude, appreciate you coming on and sharing all the alpha surrounding this.
Thank you so much for hosting me. Yeah, it was a real great pleasure to meet you and talk with you.